if we were starting from scratch with a new build or a big retrofit, what we would really want in order to have better control over our indoor air quality is an airtight enclosure. It's too bad that East Coasters are now experiencing this, but I think it's kind of going to be, at least in North America, it seems like it's going to be a near universal problem here and there.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. You can also check out our Reimagine Buildings YouTube channel for some great inspiration for both building new or renovating. In the meantime, here's this week's Passive House podcast.
G'day and welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from a very chilly Taupua in the middle of the North Island of New Zealand.
I'm Zack Semke. I'm coming to you from a beautiful, sunny Seattle, Washington.
Nice. It's holiday time. You've just been back, got back from holiday, Zack.
Yeah, that's right. So we had the July 4th holiday happen this past week. And so my family and I went up to Vancouver Island. We crossed the border into Canada and took a 2-hour ferry ride, beautiful ferry ride across the Salish Sea to the eastern coast of Vancouver Island and a short drive north to a bay called Nanu's Bay, which was just absolutely beautiful. And I could not have been nicer. I was just feeling very thankful for Mother Earth when we were up there. Where are you? I mean, what's your story?
It's the middle of the year, so mid-year break, school holidays at the moment, and we've got a bit of a family reunion going on. So we have travelled to Taupua, which is a beautiful part of the world. It's a crater lake, very close to some mountains that will be familiar to anyone who's watched Lord of the Rings. So from the top of the lake in the town of Taupua, you can kind of see across to Whakapapa and the mountain range where Ngāruhui is, which is the Mount Doom. It's a very cone-shaped mountain because it is a volcanic cone, and it's got some snow on it at the moment, which is pretty lovely on a nice day. So it is about 1 degree this morning, just as I've woken up. So it's there's a bit of ice on the ground, and staying in a very nice sort of thermal resort here, but a very much non-passive house buildings. So
right.
The heaters were cranked up. The heaters were definitely cranked up last night to keep us toasty and warm. But yeah, beautiful part of the world, and nice to be on holiday, and very far from things like wildfires, which we're going to be talking a little bit about today, but still pertinent to indoor air quality. So we're going to get into that soon. It's a kind of a short episode, but an interesting one nonetheless. But let's give a quick shout out to our supporters.
Yeah, absolutely. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stillcorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Awesome. Thank you. Now, tell us a little bit about your guest that you interviewed, Zack.
Well, John Semmelhack is a fount of technical knowledge around passive house delivery and building science. He has a couple of ventures going, including one called Comfort Squad. He has served on the Phius Technical Committee for many years, and he's a go-to source for information around how to deal with indoor air quality during wildfire smoke events. We did a Passive House on the Front Lines Wildfire and Indoor Air Quality Summit a couple of years ago where we talked about Passive House and Wildfire smoke. He was a key player in that. When the smoke was hitting New York and the Eastern Seaboard, I was thinking about John, who is based in Virginia and was also experiencing that smoke, and reached out to him so we could do a little conversation about how to kind of triage for wildfire smoke, and then how to do more structural solutions. So we dive into all of that in this conversation.
Well, John, as I've been reading the headlines around the wildfire smoke events that are impacting the East Coast, I've been thinking about you because you're the sort of the go-to guy in our community around indoor air quality, and you also have helped us with moderating and informing some conversations around wildfire smoke and indoor air quality. So it's great to have this conversation with you. Thank you for taking some time.
Oh, thanks, Zach. I'm happy to chat about it. It's too bad that East Coasters are now experiencing this, but I think it's kind of going to be, at least in North America, it seems like it's going to be a near universal problem here and there.
Yeah, right. So how do we become resilient to it? Yeah. And you've done, among others, there's this community that's grown up around kind of trying to answer that question, both in sort of short-term immediate ways, the triage approach, and then also the longer-term structural ways that we can make our buildings more resilient to these events. So I was hoping that we could touch on both, and we could start with, the short-term immediate way to improve indoor air quality during these severe outdoor air pollution events, and to touch on the Corsi-Rosenthal Comparetto Cube Box, if you wouldn't mind. What is that?
The most popular name is the Corsi-Rosenthal box. There were, in the early days, some people were calling it, for fun, the Comparetto Cube, which was named after my business partner, Neil Comparetto. We were among the folks who were really involved early on in testing out this idea for this do-it-yourself DIY fan filter box. So different names caught on, but I think the Corsi-Rosenthal box is what most people know it by. So it is a box fan. So this is like a 20-inch by 20-inch utility fan that is pretty ubiquitous in North America, at least. Many households have one or more of these fans already in their household, or you can go to your local hardware store and pick one up for $25 or $30. So it's a boxed fan that sits on top of 4 filters. So 4 high-performance filters, typically MERV 13 filters is what we're using. And you tape the filters together, and then you tape them to the fan. And so the air flows through the filter and then out the fan. So what that gives you is a whole bunch of airflow, because the box fans are relatively powerful, moving through pretty high-performance filters. And you get really great reductions in fine particles.
Right. And those fine particles, as we know, are with wildfire smoke, are extremely hazardous to our health.
Right.
So, and this is an exciting way that you can take action right away during these. I mean, these are pretty scary events, and we see these orange skies and things, and realize that our houses are becoming not safe to be in, even though they're a little bit better than being outside. So this is an action you can take right away, which is awesome, and they're also not that expensive, assuming you can source the stuff.
Yeah, and fortunately, at least right now on the East Coast, we've had a mild late spring so far. So folks who don't have air conditioners have not had a big reason to go out to buy fans for cooling. So I just went out and bought a fan at our local big box store. They had 150 fans in stock at the moment. So they had a good selection, and they had lots of filters. So of course you need the filters, you need the fans, and then you got some cloth tapes. And so those are the 3 components. And then the cardboard, you can cut up the cardboard from the box that the fan comes in and use that for your base, or to build a little shroud over the fan to improve airflow. folks will be able to see that in some of the videos or pictorial tutorials that we can uh, include that show kind of how to put one of these together. It takes
Right.
about 20 minutes, and if your DIY skills are up to the scissors and duct tape level, which I think is just about everybody, if you're up to that level, you can build one of these in about 20, 30 minutes. Yep.
So you can imagine you close up your house so that there's no more smoke coming into the windows, for example,
Yep.
and you're running this thing full blast, is 24/7 to scrub the air essentially.
Yep.
So what it doesn't address is bringing in fresh air, like basically when you're filtering your air inside, you're still getting a buildup of CO2 as the occupants inside are exhaling CO2.
Right.
So if you open the windows, it means there's more smoke that needs to be filtered out by this device.
Yep. Exactly.
So there are some limitations to this triage approach.
Yeah. So this fan is filtering fine particles. It also is going to filter. As a little side note, this whole kind of DIY project got started because of COVID. So it filters out viruses as well, because viruses are mostly attached to fine particles. But it's not going to get rid of CO2. It's not going to get rid of VOCs either. So you're still going to get, odors from outside, other, chemicals from outside or from inside if you're generating them from cooking, for instance, or you have other indoor sources of pollution. This filter fan isn't going to capture those unless those things are attached to particles.
Right.
Yeah.
So let's then pivot to the longer term kind of structural solution in our buildings. What could you describe the key elements to that kind of building integrated approach to indoor air quality?
So I think if we were starting from scratch with a new build or big retrofit, what we would really want in order to have better control over our indoor air quality is an airtight enclosure and then a ventilation system. But on the ventilation system, of course, you would want very high performance filtration, or at least the ability to swap in very high performance filtration, which I know some folks have done on the West Coast during these kinds of events. So super airtight, acid house levels of airtightness, or even better, as many of the practitioners have discovered that they can achieve, and then balanced ventilation with from an energy standpoint, you can still do energy recovery, heat recovery with your ERV or HRV, but on that outdoor air intake duct, you need very high performance filtration. And the kind of modeling and the real world practitioners' experience so far, especially practitioners who've been through multiple wildfire seasons on the West Coast, other practitioners in Australia as well, they've really found that you need MERV 16 to HEPA levels of filtration on that outdoor air duct, unless you want to do additional filtration indoors. So if you want your ERV, your outdoor air filter, to do everything for you in that airtight structure, you need that top of the line filter available. And that's for most ERV and HRV systems, that really requires a dedicated pre-filter box. Most of the manufacturers do. I don't think any of them have that level of filtration available. Might be mistaken, but I think you really need something that's going to take care of that before it hits the ERV.
Right. So it's not kind of standard issue for an HRV or ERV to have that level of filtration. And also there's for VOCs and the odors from wildfire smoke, carbon filters are helpful as well, right?
So you can, VOCs and odors, carbon, or some people call it charcoal filtration is as far as I understand, the best way to do that. And you need a decent mass of that material in order to capture a significant amount of those chemicals. It's not just a little coating on a filter is going to have a short-term impact. If you want long-term VOC removal, long-term odor removal from that outdoor air, you need like pellets of charcoal, pellets of carbon that the air is flowing over to remove those chemicals.
Right. So for passive house owners or occupants, they who are maybe dealing with this kind of wildfire smoke event for the first time, they are probably noticing that their indoor air quality levels are not great. They're probably significantly better, perhaps significantly better than a typical house. There's certainly a good foundation because they've got the airtight system. They have a filtration system that or a ventilation system that allows them to filter, but really they need to take this extra step in order to deal with the wildfire smoke of having MERV 16 or HEPA level and potentially carbon.
Yeah, exactly. Many of the owners are going to have ERVs and HRVs with MERV 8, maybe MERV 11, maybe MERV 13 filters as standard issue from the factory. And those are experiences that, those just aren't good enough to hit the indoor air quality levels that we'd really like to see for healthy living.
Right.
So they're definitely going to need to bump those up, and likely that's going to have to be with a separate add-on filter box. That'll have to be retrofitted. So that's something in my own house. My ERV has MERV 8 filters, which are fine. They do well, day to day in Central Virginia. Most of the time, we had a wildfire in the Shenandoah National Forest in 2016. So it wasn't nearly. It was actually much closer to us, but not nearly as bad from an outdoor pollution standpoint as the impact of these fires from Canada. But now, I'm thinking that in the long run, I'm going to need to retrofit a pre-filter box.
Well, that's a great segue because it was yesterday or today that you kind of made a combination of you have the structure, the foundation of the structural long-term approach because you've got good air tightness, you've got a filtration system, a ventilation system, but you just added the triage piece because you don't yet have that extra filtration, right? Yep. Yeah. And so can you walk us through the numbers of what's been going on outside in terms of the PM 2.5 and what's been happening inside your house over the last couple of days?
So at my house, on my porch, I measured with a home sensor. I measured around 170 micrograms per cubic meter, and at the same time, indoors was 60. And we really want, for really good indoor air quality, we want that to be under 5. The WHO guideline is 10 or less. But really, there's the lower the better. There is no such thing as getting too low on fine particles.
Right.
The lower the better. So I was at 60 earlier, so I actually went out this afternoon. I already had a HEPA air cleaner that I had purchased very early on during COVID. And so I'd never built one of these Corsi-Rosenthal boxes for my own household until today. So I went out and picked up a fan that we already had filters at the shop and built the box in about 20 minutes and turned it on. And I turned off the HEPA air cleaner just because I wanted to see the difference if there was one. And the DIY box actually does a much better job of removing particles. which is it's a little bit non-intuitive because we're using lower performance filters, but we're moving like 5 or more times the air. So the net performance is all about the airflow, how much airflow, how good is the filter, and then to a lesser extent, are you getting any kind of filter bypass or thing? Are you getting good distribution of the air within the space?
I have 2 of those same model, I think, HEPA filters that you have, and so after this story, I am now inspired to build myself a cube. I have the DIY skills that necessary, so I'm excited about that.
Yeah, and there's some some folks, obviously $75 is a great price point. Some folks are willing for aesthetics to do some additional modifications, some additional enclosures, especially folks who have laser cutters and things like that.
Fancy.
You can make some fancy enclosures for your DIY fan filter box and make them look, as good or maybe better than some of the HEPA cleaners. You can't get around them being big. So they are going to be big. And that's really important, is that you have a big surface area of total filter media. So just, a lot of surface area for the air to flow through. So it's low resistance. So it's easy for the air to flow through the filter. And then you have a powerful fan to move the air through the filter. Those are the 2 key things.
Okay. I'll remember that as I'm building. Thank you. Well, John, I really appreciate your time. Thank you. And I know that folks will be really happy to get some guidance on how to deal with this wildfire smoke. And we'll be probably referring to this video more times than we'd like in the future as we are dealing with these events more and more.
Right. Yeah. And there's, especially on the West Coast, the passive house practitioners and the passive house owners who have been through this, they have a lot of experience at this point with kind of what's working. They probably have some good experience with these kinds of retrofits as well. So it'd be good to do a follow up with some of them to see, okay, we talked about, some of the triage stuff that you were doing a few years ago. What have you done structurally, since then? What's working? And maybe we'll even see some kind of prepackaged products that are kind of, ready to go and really geared towards the typical airflow rates that we see for ventilation systems for passive houses, in that 75 cubic meters to 150 cubic meters, some sweet spot, pre-filter designs that are ready to go and fit into the folks' mechanical rooms and basements and crawl spaces.
Yeah, exactly. Cool. Well, thanks again, John.
Thank you, Zach.
And that was John Semmelhack giving us some great tips on, as you put it, the sort of triage approach to really dealing with the worst of the worst when it comes to indoor air quality. Obviously, this is not an end solution for the best approach, but it is certainly a good approach to dealing with that pretty horrendous conditions that you guys experienced earlier this year.
Yeah, that's right. Yeah, this of course was brought home to me again when we went up to Canada for the July 4th weekend. Now, the bargain that we make with the weather in the Pacific Northwest, we're famously gray and wet here. The bargain that we have with the weather has always been, well, the summers are the most beautiful. It's the most beautiful place in the world. It's just incredible in the summers. But now that's being marred by these horrible wildfire events, wildfire smoke events. And so we were a little bit, my family and I were a little bit apprehensive about booking this trip, honestly, because we thought, well, it could be socked in with smoke. We just don't know, right? And we lucked out, and the wind has been blowing the other direction. And so the people in the Midwest and the East Coast have been less fortunate recently. But I was definitely thinking about that as we were floating along in our kayaks, looking at this beautiful Nanu's Bay in Vancouver. And just another note is that according to the Washington Post, Monday and Tuesday were the 2 hottest days in at least the last 125,000 years. on the
That's
planet.
quite a while.
That's the average. The average temperature of the planet was the highest, right, for at least 125,000 years, and probably much longer. So we need to figure out how to address and become more resilient to these wildfires and other climate impacts that we're going to be feeling more and more. So it's unfortunately feels timely.
Yeah, that's pretty alarming to have that statistic, and it's only one data point, but combined with all the other data points that we've been witnessing and experiencing, it tells a pretty stark story, I think.
Yeah.
So I'm kind of fortunate to have a whole house heat recovery ventilation system, which is probably a little bit overkill in my situation because I was I happened to have a system that was made available, so I installed it. My house is probably not airtight enough to justify the quality of the ventilation system that I have. I probably don't get the full benefit from it. But as a consequence, I do have 2 filters on that system because it's a heat recovery ventilation, which means there's a filter on the air that comes into the house, and there's also a filter for the air that's getting brought back that's about to be expelled before that air passes through the heat exchanger. So I get to see the quality of the air coming into my home and also what the filter picks up from the air inside the home. And I am always surprised at just how much dirt and black stuff there is on that second filter, which is the air being filtered from inside my home. Because you kind of think that if you're filtering the air coming in, that everything's going to be clean. But it's amazing just how much it picks up from inside the house. But of course, the one on the outside, that's just amazing how, and I've taken photos of that in the past, just how black and horrible that is. And I live we're on a back section, so we're away from any main road. We're not in any sort of flight path. We're not near any factories or anything. That's just kind of in a fairly leafy green suburb in a major city. It still gets quite black. So in the situation where you've got wildfires, I just can't imagine how much particulate matter there must be that accumulates on those filters. And if you're not in a airtight house, then it's just going to come in through all the cracks and wherever air is getting into the home. So it's great to have solutions like this that I think are unfortunately going to be needed, but they also potentially help increase the awareness of indoor air quality and the benefits of more airtight construction.
I think so. I think that's true. And we have all of us have become much more attuned to the air quality maps and the colors, and the fact that the very worst colors are purple and maroon. That's because I was just listening to a radio story on National Public Radio a couple weeks ago. When those maps were developed, I believe in the 90s, red was meant to be the worst case, like bad air quality that we would experience, and it was kind of assumed that would kind of probably never happen. But because of the unforeseen, at least by many of us, unforeseen impact of this warming and the different issue I know there's forest management stuff too, but anyway, these wildfires, the wildfires that are happening, we're getting into the purple zone, and it's just ridiculously toxic, horrible air. So I think that one of the key takeaways here is I guess there are 3 kind of stages that we can go through to deal. Is my understanding of the takeaway from John Semmelhack. One is you can do the triage during these wildfire smokes if you have a non-passive house like my house, unfortunately still, and do the Corsi-Rosenthal box and do all this volume of air going through MERV 13 filters, which will help clean the air. So that's the first one. Second one is if you have a passive house and you don't yet have a filter box that has been added to the ERV or HRV system so that you can do the MERV 16 and carbon filtration necessary to really not really deal with that horrible wildfire smoke and the particulates there, then you can also do the Corsi-Rosenthal box, and have quite good indoor air quality, way better than I'm ever going to get in my house during these events. But finally, where passive house owners need to move and building owners need to move to sufficiently deal with this indoor with wildfire smoke and keep these indoor spaces truly safe for people to breathe the air, is to do that extra filtration. So the passive house provides this awesome, really important foundation with the airtightness and the filtration system and the controlled ventilation. It just needs a little bit more to deal with this unprecedented level of outdoor air pollution.
Yeah, the beyond red.
Yeah, it's really quite nuts. But, I guess the other thing too, though, is that with this kind of building science approach to mitigating and kind of protecting ourselves from that crappy air, the actions necessary to make us more resilient to this impact of climate change also makes our buildings smaller contributors to this warming. That's a good thing. Right. If there's this harmony between becoming more resilient and also helping to create buildings that become more and more a part of the solution.
Right, because if our buildings are healthier and requiring less energy to run at a healthy state, then we're consuming less, polluting less as well, and contributing less to the overall problem.
Yeah, exactly.
Yeah. Which also reminds me, there's a lot of talk in this part of the world in my day job and work that I'm involved in about electrification at the moment, which I know is happening in a big way in your part of the world, the States, and also across Europe, and that that's a big part of this as well, is how do we get rid of gas? I mean, in parts of New Zealand, there are still quite a lot of solid fuel heaters as well, like log burners, pellet fires, and things like that, which they have their own air quality issues with particulates going into the air if they're not these sort of ultra low emission type fires. So it's a summer wildfire issue, but I know that air quality can be a really big issue in wintertime in places like Christchurch here, Dunedin, where there's still quite a lot of people burning wood or some sort of solid fuel, and you get these calm, cold mornings where it's pretty toxic outside.
Yeah, right.
And you sort of get that same sort of air quality issue in the middle of winter as well. So good little trick. I enjoyed that, something a little bit different. But very informative, something practical that people can do. And also, as I said, I think really does raise the awareness of the importance of good ventilation and good indoor air quality. So thanks to John and thank you, Zack, for bringing that interview.
Yeah, thank you. We'll have a bunch of links that John also shared with, including instructions to make a Corsi-Rosenthal box and some other cool stuff. I also want to mention that a video version of the interview segment we're about to publish on the Reimagine Buildings channel. So go to YouTube and look for Reimagine Buildings, and you can see John Semmelhack and I talk about stuff and also see some images, I think, of the cube.
Great. Awesome. All right. We got some events coming up.
We do indeed. So at the Passive House Accelerator this coming week, Wednesday, July 12th, here in the Western Hemisphere. So that's July 13th for you down under. We have a presentation by Paul Shepsky of Geography Construction. entitled High Energy Performance with Low Carbon Building Materials. So that's a next gen episode of the show. So Paul is it represents the next generation of leadership in the space. So we're looking forward to having him on the program. And then the next week, so July 19th for me and July 20th for you, Matthew, we are joined by Mark Ginsberg of Curtis & Ginsberg based in New York City. And he is going to be presenting Buildings of Excellence, Working for a Low Carbon Future. So Curtis & Ginsberg has won all sorts of Buildings of Excellence awards and is doing a bunch of those projects in New York. So he's going to be drawing from those in this presentation of a project showcase edition of Passive House Accelerator Live. And then there's lots of other great stuff going on in the community that we share in our newsletter and Passive House Weekly. So we'll include a link to that in show notes as well.
Great. All right. Well, thank you for that, Zach. I'm going to go and see if it's warmed up at all outside. I'm pretty sure it hasn't. And enjoy the rest of the holidays here. But we'll be back again next week on Passive House Podcast.